Hello, everyone. For those who are attending now and for those who are rewatching this recording, I hope this is going to be useful and helpful, inspire you to contribute to activity. Um, so this is the outline of this training session. We're going to go over a high-level overview of what GitLab is, and we're going to dive deeper into the account creation, settings, and we're going to talk about the project, the group, and the repository overview. Then we're going to move on to examining what is issue and how to track and plan and manage projects within GitLab. And then we're going to be talking about merge requests and contributions and how is that reviewed and approved. And we're going to dive deeper into discussions, how discussions are being handled, the documentations um, from every single element of GitLab. Then we're going to talk more about the continuous integration and have a high-level overview, and we're going to examine the workflow that we are recommending. Finally, we're going to have a demo and open the floor for questions and answers. So with that. One prerequisite for this training is that it's expected that you know Git. So there will not be any training or explanation of any Git specific features or technology. It's only about GitLab itself. So GitLab, it's a fully integrated platform for software development, and the biggest advantage of it is the fact that it eliminates the need to jump across various platforms. So previously, before using GitLab, we were using Gerrit, Jenkins, Jira, and DocuWiki. Gerrit was a platform for hosting the actual repository, and it's great for code reviews. And we use Jenkins for the continuous integration, and we use Jira for issue tracking and project management, and the DocuWiki for the wiki documentations. And GitLab basically can combine that into one single monolithic solution, which includes the code repository hosting and the contribution review and approval, the continuous integration, the issue tracking, and the project management and the documentations. So the first thing we want to talk about is account creation, and it's important to note that IoTVT is an open source project, and we have made all of the IoTVT, also the onboarding tool and client repositories available publicly without the need to create an account. As an anonymous user, as somebody who doesn't have an account, you can view the code, you can clone the repository uh, and its entire development history. You can view the issues, you can view the merge requests along with the discussions that's taken place inside these issues and merge requests. And also you can have a look at the metadata associated with these, like labels and milestones and all that stuff. So if you basically want to know what's coming down the pipeline in terms of implementing features, fixing bugs, and all that, you can completely view it, read it without even having an account. You can also see the status of the pipelines and even the project analytics. But for those who are willing and able to contribute to iActivity, you can absolutely create an account. Once you create an account, then you will be able to contribute code or report a bug or an issue or create merge requests and interact with discussions that's taken place, and become a part of the solution. Um, but of course, creating an account alone is not enough. After you create an account, you will need to request access to a specific project or a specific group that you're interested to contribute to. We mirrored everything that we have on GitHub to, sorry, on GitLab to GitHub. So the repository in GitHub, um, it's it's basically available there because GitHub is a very popular platform for hosting codes. Our issues and CI pipelines and everything else cannot be viewed on uh, GitHub. This functionality is not available. Otherwise, we could use it. So the code can be viewed on GitHub and also on GitLab. Um, uh, let's talk about the account settings. So every single repository will automatically enable the HTTPS protocol. That's something you can use to clone the repository. But also, if you have an account and requested access as a developer and you're contributing, you could also push to the HTTPS protocol. But many developers, including me, prefer the SSH, and this is a functionality that's available. You can create SSH key pair and add it to your own account settings, and then you can use it. Another thing is the top navigation bar. This is basically kind of your go-to space when you first log into GitLab. It has information about your account. It has a link to the documentations. It has your to-do list, which is updated dynamically. Um, uh, and you're going to have access to the merge requests and the issues. If anybody mentions your name in a merge request or an issue, uh, this list and the top navigation bar will automatically include that to get your attention. Think of it as notification hub. Also, in this tab navigation bar, you could do some searching, and in the demo section, I could showcase all this. Just a quick overview about the available permission roles. So one of the advantages of GitLab, it has very granular access control. It's actually a very complex topic, so I'm not gonna go in details into this. I just want to give you just a very high level information about the permission roles. The first role is anonymous, is basically anybody who's not logged in. The one level above that is the guest, anybody who is just simply logged in. Another one is reporter, uh, which is basically somebody who's logged in and has requested access to be a reporter in a specific project or group, and his access has been approved. The same thing goes for developer, maintainer, and the owner is either someone who created their own project. So if you create a project within your namespace, you become the owner of that project, or if somebody else created a project and invited you as an owner. So these are the different permission roles, and just a very quick overview of the difference between these roles. As an anonymous, as I stated earlier, you can view everything. As a guest, you have everything anonymous has, plus you can actually create issues, and you have the ability to participate in the discussions. As a reporter, you have all the rights of the guest role. On top of that, you can actually engage in managing the issues. You can assign issues to individual users, you can label them, you can track them. In addition to the guest, you can also create a merge request. And then the role above that is the developer, and it's pretty much the main role. You have all the rights that reporter has. In addition to that, you have ability to manage releases. You can create a release, you can edit a release, you can delete a release. Um, you can also manage unprotected tags, and I will talk later about protection. Basically, if a tag is unprotected as a developer, you can add a tag, you could like create it, you could rewrite it, you could remove it. You can manage merge requests, assign it to individuals. You can approve certain merge requests. You can label them. You can manage milestones, create a milestone, and edit it, and delete it. So it's very so it's a role with a lot of advantages. You can create wiki pages, you can edit wiki pages. You just cannot delete the wiki pages, even the ones you created. That needs the maintainer level. You can push directly to any branch that's unprotected, including forced push. You can start and cancel and retry any continuous integration jobs and pipelines. You can also, as a developer, if you have a developer role in a group, you can actually create a project within that group. But even if you're just simply a guest, you can create a project in your own namespace. You can also, when you fork a project, that fork is going to live under your namespace. So the one level above that, the maintainer, you have all the developer rights. In addition to that, you can actually delete wiki pages, you can manage the team itself, you can add new members, remove members. You can also create subgroups. If you are a maintainer of a group, you can actually create subgroups. And also, as a maintainer, you can enable and you can disable the protection for certain branches and tags. This way, um, for example, developers will no longer be able to push to these branches or manage these tags in any way if they are protected. Also, as a maintainer of a project, you can push and approve merge requests for protected branches. So you cannot force push to a protected branch. Actually, nobody can, even the owner cannot force push to any protected branch. The only way to force push to a protected branch is to unprotected, basically. Also, as a maintainer, you have the ability to manage the GitLab runners and the continuous integration pipeline and jobs. Also, you can monitor the discussions and you can edit the comments, even the comments that are posted by others. Um, so, as a guest, you can participate in discussions. You can edit your own comments, but as a maintainer, you can, if somebody has, I don't know, like to enforce some community guidelines. As an The highest role is an owner, and you have everything that the maintainer has, but as an owner, you have far more invasive and um, changes that cannot be undone. For example, you could um, remove the project. You can delete the project, and if you delete it, it's gone. You can transfer the project to a completely different namespace. Uh, Again, if you do that, uh, I mean, you could go and transfer it back, but you have to be an owner of the other space. So if you are an owner of a group, you can move it to your own namespace, and since you are the owner of your own namespace, you can move it back. But if you move it back to a different group that you don't own, you're no longer able to transfer it back. Um, you can switch the project visibility. I'll talk more about that, what that means. You can delete issues and merge requests. So, so issues that have been solved, they can be closed, but if you completely want to delete it for some reason, it's possible. Also, same thing goes with merge requests and other permissions. Yeah, I just talked about the force push. Anyways, so next we'll talk about the kind of like overall architectural um, uh, overview of GitLab directories and such. So if you want to create a project, projects cannot be created under the GitLab root directory. Projects need to be created under a specific user namespace or under a group, and or you could say subgroup as well. And groups have the ability to include subgroups, and you have an infinite amount of subgroups that could possibly be created. And the way permissions and roles work is, think of it as a waterfall. So if somebody is a developer of the parent group, then they automatically granted developer roles under every single project underneath that parent group, and also every um, subgroup under that parent group. But let's assume if you are a developer for let's say a subgroup, then you don't have a developer role in the projects and the parent group above you. You only have what's below. So this is how the just a high level of how the permissions work in groups. Um, yeah, I mentioned that any user can create their own project or fork project under their namespace. So creating a project or creating a group. Uh, so projects can be created from scratch, or they can be created from a specific template if we want specific template to take place, or we can also create a project from an import. We could import a project from various sources, from another GitLab instance, from GitHub, from um, other like hosting services for Git projects, and you can create it in an easy automated way. The only thing to look out for is kind of a minor detail, but there are some reserved names, and I do have a slide in the backup that includes the documentation reference of everything in the training. But I thought I would highlight this just in case somebody runs into these problems. Basically, these are the names that reserved, that you cannot use them as a project name, and these are the names if you want to create a group, you cannot use them as the group name. And the subgroup, you can actually, these are protected for the parent group, but the subgroup, you can actually use any of this. You just cannot use this backward slash dash. I don't know why would anybody name it that, but just for sake of completeness, we can't use that. We do update the GitLab every month. So anytime there is an update, there could be a change, but as far as I know, it's a static list. Yeah, I mean, if you notice, some of these like refer to specific internals of the actual um, GitLab. So if GitLab enabled a completely new feature, and this feature has a name, it will be added to this reserved name. Basically,
Okay.
when you type the URL, um, these names GitLab is using for specific internal features.
Right.
Yeah. So any new feature that's added or deleted, it will reflect in here.
And if you import a project, it gets the entire history.
Yeah, yeah.
Oh,
It could actually not just the entire history, but also for example, if you import it from another GitLab instance, it can also import the issues, the merge requests, like
okay.
not just the Git history itself.
Okay,
Okay.
great.
So another thing to note is when you create a project, you need to choose the visibility. So the visibility, you have three different options. You have a private visibility, you have an internal visibility, and finally you have a public visibility. I already mentioned that all the IoTBT and onboarding tool and generic client repositories are public. So when you set something public, it's it's public. The whole world can see it. Anybody on that network, at least, you know. So if uh, our GitLab instance is available in the public internet, but if you have your own GitLab instance in an intranet, uh, in a local area network, then public, of course, you know, will allow anybody on this network. But since we have it on the public internet, then this is available for the whole wide world. Internal means anybody who has an account and logged in, who did not even request access, can see internal projects. Um, and finally, the private. The private project, it's only accessible to the owner, and the owner can invite individuals to become members into their own private project. So even if somebody logged in, um, they cannot see the private projects. If they go try to explore our project, it's completely invisible. Only admins of the GitLab instance can see a private project of anyone. Um, okay, so the next thing to do when you create a project is to review the visibility of the project tools and features. For example, issues and merge requests and the CI pipelines and the large file storage and the wiki and the snippets. Like let's say you want to make IOTBT project public, but you don't necessarily want issues and merge requests or the pipelines or the analytics or whatever to be seen publicly. You can actually disable those. And also, if you choose to enable them, you have an additional layer of granularity. You can say enable for everyone or enable for those with access or enable those for members only. And just a quick note about the difference between those with access and members only. Um, so let's say you have a project that's an internal project. So anybody who's logged in can see it, but they did not request access. Uh, if you enable the issues for those with access, then those who logged in uh, can see your internal project even though they are not a member. Uh, and then the layer above that is to say restrict this only to members. So even if your project is internal and somebody logged in, they can see your repository, but they cannot see your issues, for example, because you restrict it to members only. They have to request access to see the issues. Anyways, I hope that's clear. So yeah, when it comes to permissions and roles, GitLab is, yeah, could become a whole new training discussion about this. The next thing is membership, how to request access. So members can initiate this membership. They could go to a project, and if they are not a member, they can basically they will see a button, a blue colored word says request access. Click on it, and then you fill out the form. You choose which role you're interested in, and it doesn't grant you the access automatically. Um, the maintainer of that project or the group will have to basically see your request and approve it. and they have the ability to downgrade your role or upgrade your role. Additionally, the maintainers could invite users into a project or into a group. But of course, that user will have to have an account in GitLab. So as an owner or as a maintainer of a project or a group, you cannot invite a user who doesn't even have an account in GitLab. Uh, just wanted to make this point clear. Another thing I mentioned earlier about the group permissions and how it can follow kind of a waterfall approach. So you can actually select these individuals as a maintainer of the parent group. You can say, okay, this person has access to this project only, or this subgroup, or things like that. And every project, every group must have at least a single owner as a minimum. Otherwise, you basically delete it. But it's possible to have multiple owners. And another thing to note is when a member leaves a project or a group, all the issues and all the merge requests assigned to that individual will be automatically unassigned. So there is no need to do reactive maintenance to when somebody leaves or if someone is being removed. All the issues will be automatically assigned, which is a nice feature. Let's Okay, we talked about that. Okay, the tools. We mentioned issues. Issues basically, this is the fundamental medium for any collaboration on ideas and project management and planning the work. Um, yeah, basically think of it as an ideation stage. This is where um, we know what the bugs are, we know what the new features that we want to implement are, um, and have all the requirements defined well and all that. This is the perfect medium for that. And then we have the merge requests. So merge requests basically is a space to collaborate on the proposed contribution. So the actual contribution will be made into the merge requests, and um, if there are feedback that need to be addressed, or if there is any concern about these contributions, you can have all that in the merge requests. You can view the contribution, you can edit the contribution, you can, and I'm going to talk more about the discussions that could take place in the issues and merge requests later. But this is basically what the merge request is used, mainly for code review. And or I'm going to say contribution review instead of code review, because other projects could be just text-based, like the documentation, which is not necessarily code. The other tool is continuous integration. This is a native feature to GitLab, and it provides safeguard to the main code in production, and also it allows the mechanism to automatically roll back to a known working state. Um, yeah, in case a merge request went in by mistake and broke the code for any reason, can automatically roll back to a good working state. Another tool is protection. This can be applied to branches and also tags. Uh, so branches and tags can be protected to prevent everyone, including the maintainers and even the owners, from force pushing or delete that branch. For as long as the branch or the tag is protected, it cannot be deleted by anyone. You cannot force push to it by anyone. Um, and but the the branch and tag protection allows further permission granularity, um, uh, basically in who is allowed to push uh, to that protected branch and who is allowed to approve a merge request uh, that will merge the contribution into that protected branch. And also you can control it by roles. This is a quick just a quick note about the difference between roles and username. You can't, for example, protect a branch and make an exception to a specific individual. It's not enabled. You can have an exception to a specific role. Anybody with a developer role can do this. Anybody with a reporter role can do that. It has to be protected. Um, Another tool which is really great is the Web IDE. This is a native built-in an IDE on the web. You don't have to install anything. It's there available. And you can configure it in basically just like you would configure any IDE, like what's the indentation size, you want to be dark mode, like the theme. You can, it's pretty much like a full-blown IDE. It supports syntax highlighting. It can automatically figure out what programming language or file type it is by the extension and apply the syntax highlighting. And you have the ability to override that. It has a markdown editor. Also, it has a live preview for JavaScript. So if you're developing JavaScript in a kind of a front end thing, we don't do it, but if we were to do it for any reason, you can actually preview live objects of the JavaScript and actually interact with it. Also, it offers an interactive web terminal, and it offers a diff tool, so you can uh, diff a file across different merge requests, across different branches, um, or in in a merge request, you have access to this web IDE. So in there, you could see and review your contribution before committing, stuff like that. And Wiki, another tool that's available for every single project within GitLab. And uh, yeah, currently we're not using it, but something that we could use. Also, you have Graph. So Graph, it can display the complete history of the repository, including all the branches and tags. And it has a compare tool. I mentioned it. It's kind of part of the IDE. I thought I would highlight it because personally I use it a lot and it's very useful. And it can actually check the difference character by character. So it's a really good tool. File Finder, anywhere in GitLab, regardless where you are. If you press T, you can immediately access the File Finder and just type the file name and it will find it for you, which is, I think, it's a pretty cool feature. And finally, the analytics. This is the dynamic dashboards for many aspects of each repository. You can see, for example, the code commits, the contributors, the CI pipelines, what's going on. Um, yeah, it's basically for data visualization, figuring out the health of um, the repository and its progress. Very useful for um, project management. If issue tracking is enabled, you can also track the progress on issues and what's left to accomplish a certain milestone and stuff like that. Issues. So issues space for reporting bugs. I think the name issues is kind of misleading because you could actually um, suggest a new feature, not necessarily report a bug. Um, so that would be a good place for it. Yeah, and then clarify all the implementation, and you can track the status. Another thing just to show you the depth of the permissions and the complexity of it, issues have confidentiality um feature where, let's say, maybe we discover some kind of like cybersecurity flaw that we don't want anybody to know until it's fixed or whatever. If we want to have a confidential issues for any reason, we can flag an issue as confidential, and this will override the issue visibility that we talked about earlier. Um, so anybody who's not member won't be able to see it. Even members with a guest role cannot even see it. One important thing to note is if a guest, because guest can create issues. If the guest flag this issue they created as confidential, they can see their own confidential issues alone. They cannot see anybody else. Um, and what's cool about issues is the organizations. So you can organize. So first of all, you have the issue page. Um, the issue page contains all the information about the issue. Um, and on top of that, you can organize um, the issues into lists. Just 1 second. Yeah, so basically issue page is I'm gonna show you later, but it contains the status, the author, the summary of tasks and threads, and who's signee, and which milestone it belongs to, if it has a due date, and the labels and stuff like that. And the issue list, um, within the list, it's possible to bulk edit the issues and filter out the lists based on certain properties, such as a label or milestone, for example. Um, so you could have a list for all the issues that belong to a specific feature, or maybe a list for the top priority features or bugs, another list for um, maybe the lower priority issues, another list for um, the CI pipelines issues or features or stuff like that. Multiple lists can be made, and then on top of that, you could have issue boards. So each issue board, it just allows you to use whatever project management philosophy you would like to follow. Let's say you want to have a board for maybe a Kanban board where a list has uh, a backlog, and another list inside that board will have the work in progress, and finally a third list within that board that has the done and completed um, issues. Or maybe you could have a board for a sprint. And the beautiful thing about it, it's every single developer could have their own boards and organize their own issues um, however they see fit. Any issue that belongs to them and they want to work on it, they could manage it, organize it, in whatever makes sense to them. And you can have multiple boards. Even a single developer could have multiple boards for different purposes, for different views of the health of the project. Another thing we're going to talk about is the merge requests. So this is so the purpose of the merge request is to review the contribution and provide some safeguards to protect the main production code. So certain um, safeguards include the approval process. So contributions needs to be reviewed and approved before merging them, and also the continuous integration. So the the, the CI pipelines can be enforced to pass before merging any contribution. Um, So that's another safeguard. Also discussion. I'm going to talk more in details about discussions, but within discussions, you can have threads, and you can enforce that all threads must be resolved before merging requests. There is no open concern, there is no open discussion. So this is a feature that can be implemented to basically enforce that before merging any contribution. Finally is the conflict. If there is any conflict, that will basically block the merging. Uh, um, the, that will block the merging conflicting uh, contribution. So the conflict will be resolved within the merge requests, and then it will have to pass the CI pipelines, and if the thread resolution is enforced, then all the threads will have to be resolved. Then finally, whoever has the right and permission to approve the merge request can finally approve it. So it just provides you with a lot of safeguards to make sure that any contribution to the main production is safe and sound. So if you have a confidential issue and you create a merge request from that confidential issue, that merge request will also be confidential, and it will no longer have like a normal public uh, branch. It will do a complete fork into uh, uh, a different namespace to and completely isolate that. So this contribution will of the merge request that's confidential will be completely private. Basically, it becomes a private project, and then you could invite individuals. Okay, discussion. I really had to kind of have a dedicated slide for discussion because the discussion within GitLab is really, really rich, and we're not taking advantage of it. So the discussion in general take place in issues, can take place in merge requests, can take place in snippets. Also, it can take place within pictures. So if you have, I don't know, like let's say you have a user interface you want to review for some reason, you can actually like point to a specific thing, and uh, at the coordinates of that picture that you clicked on, there will be an icon. Within that icon, you can start a discussion there. You can have threads there, um, um, just to kind of like review user interface or whatever. Uh, Maybe something we can use for the OTGC, for example. And discussions, you can have simple comments, or you can start a thread. And thread is a special thing within discussions. Um, uh, Also comments. If you had a comment and then somebody replies to the comment, it automatically is converted to a thread. So threads also can be locked in and unlocked. So a maintainer could say, okay, we talked enough about this and we resolved it. This discussion is locked, for example. Um, and you can label a thread as resolved, and all the threads taking place in an issue, for example, or the merge request can be aggregated. So you can see like the total number of threads and how many of them have been resolved and how many of them have not been resolved yet. And it just really simplifies the discussions. And also, if there are threads that are not resolved, but the merge requests will need to be merged in. Let's say you started a merge request and the discussions took place, and then a new work that has been discovered, uh, or maybe like, yeah, a new feature that we want to implement, but it doesn't necessarily affect this particular merge request or not necessarily affect this particular issue. You can actually start a new issue from unresolved threads. And you could do it as singles or as bulk. If there are multiple threads and all of them are unresolved and all of them talk about a specific topic that's not really part of uh, the current issue or the current merge request, you can select them all as bulk and start a new issue with them. This way, uh, you will have all the resolved issues. So this is useful, for example, if we decide to enforce the thread resolution in a merge request before merging. Then if we have unresolved threads, but we really want to merge it in because we think it's a completely separate thing, we could completely create a new issue from the unresolved threads to work on it later, for example. And what else? Yeah, I mentioned about the possibility to enforce the resolution. Also, you can have inline threads. Let's say in a merge request, you're gonna have multiple commits, and within each commit, you can have a inline discussion inside a specific line of a specific commit inside the merge request. Also, it supports discussion and inline threads inside a commit difference. So if you check the diff, and you can actually write a discussion, inline discussion for a commit diff. And the beautiful thing about this is that if there is another push that addresses that specific line that the discussion is on, the threads in that line will be automatically resolved. But of course, this is not enabled by default. Something we'll have to enable if that's something, if this is a behavior we would like to have. Um, if because if you have a line and it started discussions and then a new push changed that line, does that mean all the threads have been addressed, or do we still want to manually close them? So right now the default behavior is to manually close them, um, but we could enable that if that's something we're interested in. Yeah, I talked about the discussions on pictures earlier. Yeah, also this discussions support the industry standard Markdown. And then on top of that, there is a GitLab flavor Markdown, which includes many, many things. Uh, but the thing I want to highlight is the GitLab on references, such as users. You can have an @ or issues. If let's say we are having a discussion, an issue, and we discover some issues that are related, we can put a hashtag and then the issue ID or the name. Same thing with a merge request or a label or a milestone. Also, if you want to reference a specific commit, you can type the first 8 characters of the hash of that commit, and it's going to be give you a hyperlink to that commit. These are kind of like all these features that are available in a wiki, basically available in the discussions within issues and merge requests. Also, there is support for task list. So let's say with an issue, we define specific tasks. You can enable that, or you could have a table of content. And the nice thing about the task list, it, just like discussions, it can be aggregated. So you can see like how many tasks there need to be accomplished, how many of them are done, how many of them are not done. You can check them and check them. It's another thing that helps with the project management aspect. So continuous integration, obviously one of the most important features of GitLab, and the way to enable it is to have a configuration file, a CI configuration file. So by default, the name of the GitLab CI is dot gitlab-ci.yml. So this is a YAML file, and the default path is in the root directory of the repository. However, the name and the path could be changed if desired. Also, if desired, you could have multiple configuration files in multiple directories and link them together. Think of it as like what we did with the scones file in IOTBT Classic, or the make file in activity light or any other C project. It's pretty much, think of it as a make file or a scones file. And so this configuration file defines the structure and the order of the pipelines. And you can see it has jobs, and then you can wrap these jobs into a stage. Maybe you have a stage for building, a stage for testing, a stage for deployment, or what have you. And then the whole thing, this is what's under the project pipeline. Yeah, every project could have their own image, Linux or Android or Windows or whatever. Also, each job can execute a script directly, or you could take the content of that script and you could embed it into the job, into this configuration file. And another thing to note to kind of understand how it works is there's another software. It's called GitLab Runner. That software, um, this is what actually executes that CI configuration file. And this software can be installed on basically any machine, including the machine that's hosting the GitLab software. So right now we do have a few GitLab runners installed on the actual instance, but pretty much any developer can install the GitLab runner on their own machine if they want to execute the CI locally, for example. And it could be installed on various different type of machines. You could install one on a Raspberry Pi, you can install one on a Linux machine, you can install one on a Windows machine, you could install one on a Macintosh machine, for example, or whatever. And inside the runner, you can specify like an executor. Uh, I didn't mention it here, but it's part of the GitLab runner. So a GitLab runner will have multiple executors. You could have a Docker container. So if you don't really care about the machine itself that's hosting the GitLab runner, you want a container that will execute that job. You could have the GitLab runner to basically have a Docker as the executor, or you could have a shell um, executor. If you want, for example, if the actual machine that you have, if you want to have access to the hardware of that machine or stuff like that, then you could change the executor to be basically native. So the GitLab runner is a software written in Go, so it supports multi-threading, and anything that can run Go can run a GitLab runner. It's very useful. And when you install a GitLab runner, you have the option to make it available and shared across all the projects and groups in the GitLab. This is called a shared runner. Or you can have that GitLab runner be dedicated to very specific project or very specific projects or a specific group or specific groups. Also, multiple GitLab runners can be available for a single project if you want to run, if you want to have like a parallel execution of jobs to save time. You have the resources and you want to execute fast, you can have multiple runners for the same exact project. So every single job under a stage can be executed at once at the same time, assuming they're not dependent on one another. If they are independent jobs, you can run them um, in parallel. And ideally, you want any job that depends on another job. Ideally, you will put that in a different stage. And also the opposite is true. You could have a single runner, have access to multiple projects can use it. Also, runners can be labeled. So let's say you have a project and this project has multiple runners, um, but you want to run the job for a very specific runner. Then you could actually mention that label, use that label to execute, even though you have access to multiple runners, you want this particular runner to execute this particular job, you could do that because of the ability to label the runners. Okay, so the final thing, which is pretty much the most important thing, is the workflow. GitLab is very, very flexible. It allows you to adapt to whatever workflow your organization allows or wants or prefers. Uh, but if we don't define a recommended workflow, the contribution is going to be really chaotic. So this is basically what we have agreed on, and we want to follow this. So the first thing is to create an issue, report a bug, suggest a feature, um, discuss it, clarify it, prioritize it, organize it. Once that's done, you can create a merge request from that issue. This is important because you actually can create a merge request without an issue, but if you create a merge request from an issue, the merge request and the issue will be synced, and uh, they will automatically uh, and autonomously update each other. So this definitely reduces the overhead in maintaining the project and managing the project. It is possible to create a merge request and then link it to an issue, but that's just an extra work that could be avoided if we follow this recommended workflow. Once that merge request is created, it will also automatically create a feature branch or a source branch that's separate from the main branch. Um, in that source branch, you can implement that solution. You can iterate over it. Um, any commits and any contributions in that source branch, it would live in this source branch alone. So this is kind of your own private workspace that you can develop this implementation. Once you're happy with the implementation, then the next step is to make sure you address any continuous integration pipeline failures. Um, so once you're done and the CI passes, all the jobs are working across all different environments, then you add a reviewer, an approver. And then we go into the code review stage. Whoever the reviewers and the approvers can look at your contributions, they could check out your branch, they could do whatever they need to do to get to basically give you their buy-offs. And if they have feedback, you go back to the implementation of the solution. And once you're done and happy with it and addressed all the feedback, again, this could trigger CI failure, make sure that's fixed. And then finally, it goes back to the code reviewers. And if they're happy with it, then we finally go into the final stage, which is the merge contribution. Um, but a very important step here is to check the options to squash the commits and to delete the source branch. This way, uh, for a commit, we have specific templates. We want a title, we want description, we want a signature. Um, it's going to be really hard for the developers to abide by all these in every single commit they make when they are in the middle of development. This way, uh, if we decide to squash them, this way the developers can make a lot of commits. So they don't have to worry about the messaging. They just write whatever makes sense to them, knowing that once this contribution has matured, all these commits will be squashed into one commit that thoroughly explains what the contribution is and why it's there. Also, it's nice to choose to delete the source branch. There's no lost history whatsoever. Um, and it is possible to basically, after the fact, we could go back to the directory and figure out which branches are stale and prune them. But if you kind of like choose to delete the source branch, this is kind of like cleaning up to yourself kind of thing. It's proactive maintenance of the repository. Um, of course, there are specific cases where it makes sense to have another branch, um, but for general contributions, we don't necessarily want a specific branch for every single issue or for every single bug fix. So this is the complete recommended workflow, and then once that's done, we could do that again for every single issue or a feature or what have you. Okay, so a demo. I'll just demo a few things um, quickly and then answer any questions you may have. So this is our GitLab instance. It's gitlab.iwd.org. And I just want to show you the SSH thing. You click on this icon, you go to settings, and uh, you can see SSH keys. You add the public key. If you don't know yours, you could if you want instructions on how to generate one or add an existing one, you can click here. There's documentation available for you. Tells you exactly, gives you the command lines you need to use and everything. Another thing to note is this to-do list. So this is my go-to thing. As soon as I logged in, I go to to-do list. Anybody mentions me in an issue, anybody mentions me in a merge request or anything like that, here it automatically is updated, and I could leave it as done. Um, Also here are the merge requests. Uh, Basically the same thing as to-do list, but filtered by only merge requests. Same thing with issues. And also you could, let's say you want to go to this issue, and uh, you could here you could add it to your to-do list. It's something you care about, you want to follow, you can do it here. Um, by the way, this is the issue page. You can see the issue title, description, you can like and dislike. Here's where you can create a merge request. Um, Here are the metadata information. Here's the confidentiality, what labels, what due dates. If we enable time tracking, like let's say if we want to have an estimated time and then track the time spent, we could do that here. But this will you will have to learn quick actions, which is another like kind of shortcuts, kind of like code within the discussions. To allow you to track time. And actually, every single thing here can be edited and changed by this thing called quick actions. Um, you can lock this issue. You can subscribe to notifications to be notified if anything happens here. You want to know about it. And yeah, so here when you open a project, so this is the project documentation. Yeah, you can see here like you can go to the issues. Here's the list of issues. You can create one. Um, you can have boards. I didn't make any boards here, but this is what you could do. So these are the default ones. You can see here's open and maybe work in progress and closed. Um, Labels, milestones. What else? And it's actually worth noting this particular repository. We have getting started guide, um, explains how you basically create an account, how to request access, setting up the SSH, and what's the workflow. It's pretty much what we talked about earlier, cloning projects and different methods and issues. It's very with pictures and everything. I would definitely highly recommend that you take a look at this. And what else I want to show you? The CI pipelines. Actually, I'm going to go to the activity project, um, activity light, since it's the richest CI pipelines. You can click on it. And actually, I'm going to log out to show you what you could see as an anonymous user. So right now I am completely logged out, and you can see all the projects. Here, click on the CI pipelines. Defaulted to the schedules. You can see the status of all the pipelines. You can click on this, for example, and here is, for example, we have the build stage and we have 4 different jobs. Um, you can click on an individual one and you can see an actual console of everything that has taken place. Not sure why it's taking so long to update, but it's almost like you are on the actual machine and you can see all the logs that are reported. Um, yeah, it's very useful. And is yeah, wiki here, analytics, show you some analytics. Um, you could see the health of the project, all the failures in place, what happened. You can check the repository, how many commits, and uh, which programming languages there are. Um, this is the number of commits per day in a month or per day in a week. Um, what hours? Yeah, it gives you a lot of insight. Here's the wiki, create it. But since I am anonymous, I can only suggest I cannot actually create it. Snippets, um, it's like if you want to write a code that you want to share with someone that's really like maybe an implementation you're considering. So it's not necessarily a branch of a repository or anything like that. It's just basically think of it as a scratch file. Basically, this is what a snippet is. You can create one, but you have to be actually registered and share it with others. Hey, what do you think of this implementation? This is maybe a cool thing to do in Python, and how you maybe, yeah, stuff like that. I don't know, like list um, comprehension or whatever. Uh, yeah, so to discover projects, click here. It, here's you click on all projects, you'll see, and we have made this as the default page. If you go to gitlab.itb.org, it will default to this page. This way you can see all the projects that are public. You can see which projects are trending, or which projects have the most stars. You can go to groups. Right now we have only these 2 as public. We have more groups that are internal, but this is the public ones. So that I wanted to show you. Is there anything else I talked about that you would like to see as part of the demo? Okay. I just left the slides. Of course, this recording, these slides will be available. Um, Here are links to if you want to dive deeper to the documentation and figure out more about merge requests, more about CI, more about groups.